Hello everyone, and then welcome to another video. Okay, so in this video we're talking about basically the introduction to thermodynamics. Okay, so in this video I won't be going much into the theory aspects. Okay, so I'll be just pinpointing or just highlighting the most significant or the most important concepts you need to know. Okay, so we are just going right into the introduction to thermodynamics. Okay, so let's dive right into this video. In case you are new here, kindly subscribe. Okay, I'll be uploading series of these videos to help augment your study. So subscribe and then kindly like the video. Okay, so once you like the video, the YouTube algorithm will help students who are also in need of such videos to get access to them. So it's very important to also like, and then in case you have any questions, just leave them down in the comment section below and I will respond to them. Now let's dive right into this video. So we'll be talking about gas laws. Okay, talking about gas laws, right? So as I stated earlier, there are some things you need to know, okay, and then there are some things you don't need to know. Okay, so we'll be just treating the most salient, okay, points, okay, or concepts you need to know. Okay, right? So first, we know that we have the Boyle's law. Okay, have the Boyle's law, and then it's being represented in this format. Okay, so for Boyle's law, you know that pressure has to be inversely proportional to volume. So we have something like this. Then when you simplify this further, you have pressure to be equal to a certain constant K divided by volume. Okay, so once you try making the pressure or the PV the subject, or making the constant the subject, we have pressure times volume. Okay, so let's move on to Charles' law. Okay, we have Charles' law. So for Charles' law, you know that volume has to be directly proportional to temperature. Okay, so once you introduce your constant, so you have V equals KT. Okay, so let's make the constant the subject. So you have K is equal to V on T. Okay, note that we are just treating the most important concepts. Okay, so let's move on to Gay-Lussac's law. Okay, I have Gay-Lussac's law. Right. So for Gay-Lussac's law, pressure is directly proportional to temperature. Okay, so let's introduce a constant. So you have pressure to be equal to KT. Okay, and then making K the subject, we have pressure divided by temperature. Okay, so one thing you need to know again is the Avogadro's law. Okay, have the Avogadro's law. Okay, Avogadro's law. So for Avogadro's law, volume is directly proportional to number of moles. Okay, so let's introduce a constant. So we have V equals Kn. Let's make our constant the subject. That will give us V on N. Okay, and then let's look at the last law. Okay, you have Graham's law. Okay, have the Graham's law. Okay, the Graham's law is the law of diffusion. Okay, it's the same as the law of diffusion. So for Graham's law, we know that our rate of diffusion, that's A, okay, has to be inversely proportional to the square root of our molecular mass. Okay, yes, so this is how we represent it. So when you simplify this further, we have A, our rate of diffusion of the gas, to be equal to 1 over square root of our molecular mass. Note that these are the most important concepts, okay, you need to know. Okay, the most important concepts you need to know. Okay, right. Okay, so we have that, and then the last one. So now, one of the key points you need to know, okay, is where we combine the gas laws. Okay, so most definitely we will be combining the Boyle's law, Charles' law, and we have like maybe the Gay-Lussac's law. Okay, to find general gas law. Okay, so we have the combined gas law. Combined what? Gas law. A combined gas law gives us what? PV on what? T equal to what? The constant. Okay, so this is for one state. Okay, so let's say we have two states. Okay, for two states, since you know that K is equal to PV on T, so it could be just simplified to what? P1 V1 equals what? T1, which will be equal to what? P2 V2 on what? T2. So this is another important what? Formula you need to know, okay, for gas laws. Very important. Okay, so I will even state this as what? Equation 1. Now let's move on to what? Boyle's law. Okay, let's move on to Boyle's law. Let's expand more on what? Boyle's law. Okay, so as I stated earlier, we combine what? The Boyle's law, Charles Fourier, what? Gay-Lussac's law to find what? Our combined gas laws. Okay, right now let's dive right into ideal gas laws. Okay, so for ideal gas laws, there are some properties you need to know. Okay, so just go through your notes, you get to understand them. They normally come in what? Your exams. Okay, there are three main what? Properties you need to know. Okay, so just go through them and then you get to understand. So let's dive right into the technical aspect of the ideal gas law. Okay, so we know that for ideal gas law, the volume has to be equal to what? The number of moles times what? The rate and then the temperature. Okay, so that's what our ideal gas law. Okay, so let me write it in its simplest form. Okay, so we have what? The ideal gas law to be equal to what? Our pressure times our volume, which is equal to the number of moles times the rate multiplied by our temperature. Okay, so note that your temperature should be in what? Degree Kelvin. Okay, right, it's very important. And then your N, okay, is what? Your moles, the moles of the gas. Okay, moles of the gas. And then we know that N as the number of moles is what? Mass over what? Your molar mass. Okay, very important. Let's say this is equation 3. Okay, and this is our equation 2. Okay, these are equation 2. Now let's dive further. Okay, so let's talk about kinetic gas equations. Okay, so we have what? Kinetic gas equations. We have what? E. Okay, has to be equal to 3 on 2 nRT. Okay, so still we know that N is equal to what? Moles of gas. Okay, moles of gas. Right, so this is our kinetic gas equation. Okay, it's one of the most important equation in what? Thermodynamics. Okay, so that will be another salient equation. Okay, so we number that as what? Equation 4. Okay, and aside the kinetic gas equation, we have what? The average kinetic gas equation. Okay, so let's take a look at what the average kinetic gas equation is. Okay, so since we know that certain E has to be equal to what? N naught of E of this, thereby we know that N naught is the what? The number of gas in 1 mole of a gas. Okay, the number of gas molecules in 1 mole of a gas, that's what? N naught. Okay, these are what? Number of gas. So in case you know what? The number of gas molecules in 1 mole of a gas, you can just simplify this as being what? The Avogadro's constant. Okay, yes, because Avogadro's constant is the number of molecules in 1 mole of a gas. Right, so let's further simplify this. Okay, we want to find out what is the average kinetic what? Energy. Okay, so we have what? Let's make E the subject. So we have E is equal to what? Capital E on what? N naught. Okay, and then we know that E is equal to this. Okay, this is our E, so we can just simplify this further to what? That by substitution. Okay, we know that E is equal to this expression. Okay, so we have what? A certain 3 on 2. Okay, RT. Okay, and then divided by what? N naught. Okay, so from here we could notice that we have our average kinetic what? Gas equation to be equal to 3RT divided by 2 n naught. Okay, so note that this is our kinetic gas equation, average kinetic gas equation. Okay, so we have another equation 5. One thing you need to know is that thermodynamics is all about formula work, okay, and then understanding the concept. So once you know the concept and then you know the formula, you are good to go. Okay, so it's just like knowing concepts in certain courses and then knowing the associated equations. Okay, so we started from the basic the gas laws. We derived them, and then we tried to find out our combined gas law, and then we moved on to ideal gas laws. Okay, so and then you move on to kinetic gas equation. Then we have average. Okay, so this is our average. You could say average kinetic energy. Okay, average kinetic energy. This is our average kinetic energy of a single gas. Okay, you could notice that I didn't introduce any n. So in case I introduce a certain n over here, it means that the gas is not maybe single, it might be maybe 2 moles. Okay, right? So yes, it depends on the question. Okay, so this is for a single gas. Okay, this is just for a single molecule. Okay, just for a single molecule. Right, so let's dive right into solving some questions so that you get to understand the concepts. Okay, let's say you've been given a certain question, maybe question 1 to so from here we know that we are calculating kinetic energy of 2 moles. Okay, so we have our solution. We have solution to so first you write out what we've been given. Okay, so from here you know that we've been given n to 2 moles. Okay, and we've been given temperature to 50 degrees Celsius. So from here let's convert the 50 degrees Celsius to Kelvin. Okay, we'll convert the degrees Celsius to Kelvin, and then we've been given R to be equal to 8.314 joules per Kelvin per moles. Okay, so now we know our kinetic energy equation. Okay, know that our kinetic energy equation is E equals 3 on 2 nRT. So all you have to do is just insert your values. Okay, so you have 3 on 2 multiplied by the number of moles, that's 2. Okay, and then multiply by R is 8.314, and then multiply by your temperature. Okay, so you know that our temperature is 50 degrees Celsius. So let's convert that to Kelvin. So you have 50 plus 273. Okay, so when you compute all of this, you end up with 8056.27 joules. Okay, so this is how you solve for this kind of question. Okay, so let's move on to another question. Okay, so let's say you've been given another question, maybe let's say question 2. Okay, and then you are told to calculate the average. Now you are calculating average kinetic energy. Okay, so the first question was for just kinetic energy. Okay, kinetic energy. So the average kinetic energy of an oxygen molecule. Okay, so this is where you have to know that you are using your Avogadro's constant. Okay, oxygen molecule. Okay, oxygen molecule at 50 degrees. Sorry, this is 0. This is 0 degrees. Okay, wow, that's really low. 0 degrees Celsius. Okay, so and then you've been given our rates. Okay, to be 8.314, right? And then this unit is joules per Kelvin, and then per mole. Okay, now let's proceed. Right, so you know our average kinetic energy equation. Okay, you know our average kinetic energy equation, okay, to be equal to E, the setting E equals 3 on 2 nRT. Okay, and then divided by n naught. Know that the n naught is Avogadro's constant, but from here you could notice that we weren't given any n. Okay, so you can just omit it. Okay, so we have E to be equal to 3 RT divided by 2 n naught, and then note that your Avogadro's constant, or Na, okay, is equal to 6.022 times 10 exponent what 23. Okay, this is your Avogadro's constant. Okay, so keep this in mind. Okay, keep this in mind, very important. So now let's proceed. So we know what R has been given. R is being given over here, so we know R is 8.314, okay, joules per Kelvin per moles. Okay, and then we know what T to be what 0 degrees Celsius, and then we convert that to what Kelvin. Okay, and then we know what N. Okay, these are N naught. Okay, right, so let's do the simple calculation. So you have what average kinetic energy to be equal to 3 times what R, that's 8.314, okay, times what our temperature. Okay, that's what 0 plus 273 divided by what 2 times our Avogadro's constant, 6.022 times 10 exponent 23. Okay, so when you compute this, when you compute the whole of this, you end up with what 5.65, let's say 358. Okay, let's end it here. So we have 5.65358, okay, times 10 exponent minus 21 joules. Okay, so this is how you calculate for average kinetic energy, and then what kinetic energy itself. So when we talk about general form of the ideal gas, you could notice that we had our the combined gas equation, and then we had our ideal gas equation. So in case you've been given for this, you'll be given what a certain pressure, maybe a pressure of 1, maybe you've been given P1 in an equation. Maybe in a question you've been given P1 to be maybe 2 atm. Okay, you have to take note of the units. Okay, and then you've been given let's say V1 to be let's say 20 centimeters cube. Okay, and then maybe T1 to be maybe 20 degrees Celsius, and then maybe P2 to be let's say 3 atm. Okay, let's say T2 to be maybe 50 degrees Celsius, and then you are told to find what your V2. Okay, so all you have to do is just make sure that all the units are coinciding, and then you find what you use this as equation to find out V2. Okay, it's just change of subject. And then for ideal gas, you might be given what a certain pressure. Okay, pressure in maybe 50 pascal. Okay, 50 pascal, and then you might be given maybe the number of moles to maybe 0.3 moles. Okay, and then you might be given your maybe temperature to what maybe 50 degrees Celsius, and then maybe you are told to find what V. Okay, so all you have to do is just insert them into your formula, and then you end up with what your final answer, because you know already that R is equal to 8.314, okay, joules per Kelvin per moles. Okay, so this brings us to the end of this video. Kindly subscribe, share, and then hit on the bell icon so that you don't miss out on any uploaded video. Like the video so that it gets pushed to other students who might need this video, and I'll see you in the next one. So we'll be solving lots of questions and then dive right into what first law of thermodynamics, second laws, and other stuff. Okay, see you in the next video. Bye bye.